Welcome to my channel, STEM Cafe, where we make everything science, technology, engineering, and mathematics. Easy to comprehend, assimilate, fun, and entertaining. Today we want to treat circle. We start with the measurement, and later we go into the geometry. You know, when we talk about measurement, we talk about the length of the perimeter, and we also talk about the area of the surface. You know, this is where we talk about perimeter, and this is the area. Now, what do you think circle is? Circle is a special shape. No edges, you know. It's just continuous. Let me just put it that way. And the special thing about circle is that it has a center where all the other parts on the circumference is equidistant from the center. How do I mean? We have a center here, and every point on the circle has equal distance from every point on this circle like this, we refer to it as circumference, is equidistant from the center. That is, if you point one line from the center to this point, it will be R, and from this point to this point it will be R. So distance from center to the circumference is referred to as radius. So this is the most important thing to know in circle. Once you know radius, you can do so many other measurements in the circle or on the circumference. Now, before we look into another thing, I believe we know that the angle at a point is equal to 360 degrees. That is if we measure it in degrees. Now, we also say that total angle of rotation, is also equal to 360 degrees. So, with this, it means that we can cut the circle into different parts. But once we know the angle that is subtended at the center, we can measure the length of the cut parts. You can measure the area of the cut parts. Now, since we have known radius and angle at a point, or total angle of rotation, we can do so many things with the circle. Now, let's look at other definitions. Please, I need your attention so that after this lecture, you won't even need to go and start reading again. It's something you can watch once and get. I also implore you to subscribe, share, comment, please, if you haven't, to encourage us. And if you have any question to ask, you can do it through the channel, or you have any advice. Whatever you can do to assist us, please, it's welcome. And we also have classes too. We have been doing classes for people that are moving from one level to the other. So, whatever topic you feel like you can treat, just send, and I can assure you will do. Now, let me go on with this. Since you have known the total circumference, we can cut it. And we have known the area, we can cut it. Now, let's look at this. A part, when we cut this part out of the circle, this place is referred to as arc. You can see, this place is referred to as arc. But this area here, this area is what we refer to as sector. You can see, arc is along the circumference, sector is in the surface, just above the area. Now, let's look at another thing to consider. When you join two parts like this, on a circle, this line that joins this place to this place, we call it chord. This line to this place, we call it chord. Please take note, we are talking about like 5 things now: radius, arc, sector, chord, and the angle at the center. Now you can see, we are talking about the chord touching these two places. The chord now, as it is, it has cut the circle into 2 parts. We call these parts segments, and this place is segments. So this is major segment, this is minor segment. So this place is now segments and segments. So to make any measurement about the segments, you will have to know some things about the chord and the angles of the at the center and some other things. So you can see segment and sector. You can see that there is difference. The segment is due to the chord, But the sector is from the center, and it is cut by the radius. Two radii, sorry, please. By two radii that brings out the sector. So this is it. You can see sector now. And you can see segments. So you can see it is so easy to understand. Now, there is a special chord, and this special chord is what we refer to as diameter. I just said there is a special chord. This special chord is referred to as diameter. It is the longest chord in the circle. I told you something. From the center, we have R to this place. Now, if along this line, we cut it to this place too will be R. So you can see when we join these two together, we have the sector. This is the longest sector, and it is the diameter. It passes through the center. Chord that cuts through the center. The diameter. So this diameter is the longest chord, and it is equal to 2 times radius. So you can see it is equal to 2 times radius. Very easy to know. So this one and this one now. So here we have diameter. Now since you have known this little part now, you can do little calculation on the circle. Now let's go into some calculation. Measurement now. Let's go into measurement now. This is R. And we know that the total angle in the circle now is 360. 360. So we can do some things. That is, if we cut the arc here, it will be proportional to the angle that is cut it, or that you cut to make that arc. The sector too will be proportional to the angle that you cut it with. Let me explain. The total area of a circle, is calculated with R and with a special constant we call pi. So we multiply pi with R squared. That is area. Circumference is like perimeter. So it is length will be equal to 2 pi R. So you can see circumference is 2 pi R. It's for the whole circle. Area is pi R squared. It's for the whole inner side. Now, if I have this theta, you know, since everything is 360, this part that I want to cut, the length of the arc will be equal to theta over 360 times 2 pi r. 2 pi r. So you can see that is for the arc. Now, if I want to calculate the area of the sector inside, it will be equal to theta over 360 times pi r squared. Which means that if I want to calculate the sector, the arc, I will need to know the angle at the center. Or I will calculate, my calculation must bring this about to make it easy for me to calculate this. So that is one of the common calculations we do in circle. Now let's look at possible calculation involving chord. You know, I told you major segments, minor segments. Now there are some things you can know in case you are not given the length or what calculation can come up. If you know what the radius is, and you know this place will be the diameter. If you are given the distance of this one from the center, let's call this L. You can easily find the length of the chord. And even with this, you can find this angle here. You can find this angle here. And then you can do some other calculations. It's very simple. If I have known R, this is R. This place will be R. This is L. You see, this is L now. I am talking about calculation involving chord. The distance from here to this place is L. So let's make it AB, OC. That is center. Now, since I have known this one, this is R, and I bring one line from it down here, you can see. So I have cut it like this. This place is 90, this place is 90. So I'm having similar triangle because this line is common to the two. Automatically, this place to this place is equal to this place to this place. So let's make it D and B. No. Let's make it H and H. So with this now, if I have L, I know R, I can easily find this angle. And what is this angle here? Let me give this place theta. So it means that this place will be theta over 2. So L over R will be equal to cos theta over 2. So which means that theta over 2 will be equal to R cos L over R. So theta will be equal to 2 times R cos L over R. That is one possible calculation. Another calculation that might come up is if you are asked to find this length, the length of this arc AB now. Since you can find this angle now, you can easily use it by saying theta over 360 times 2 pi r. You can see so many things can come up from this place. You can even be asked to find the area of this place. Okay, let's try and see. How can we find the area of this place? You know, we have seen by knowing the length of the chord, by knowing the distance of the of the chord from the center, you can find the angle. Now, you can also find this angle just by knowing the length of the chord. If you know length AB, so theta over 2, sine theta over 2 will be equal to half, because this is half of it, CB over R, which is half AB over R. Therefore, you can now say theta over 2 is equal to half sine AB over 2R. So theta is equal to 2 half sine AB over 2R. So I just trying to show what kind of calculation might come up when you have different parameters. Now you can see this is just, we have just been able to bring out rectangle triangle from this. So what I was talking about is if I want to get this area, how do I do it? I will get the area of the whole sector, and from there I will subtract the area of the triangle within. Let's see. Now, trying to find the area of segments AB minor segments. Since we know this, we know how to find, in case we have shown that if you are given AB or you are given the distance from center to AB, you can find this angle. Now, if I cannot find the angle, I can find the area of this sector. I can even find the area of this one as well. So let's see. Let's try to find the area of the minor segments. Area of the minor segments will now be this theta. After I have found this theta over 360 times pi r squared. This is area of segment. Now, area of this triangle. I will find the area of this triangle by saying area of triangle AOB will be equal to 2 times area of triangle OCB, and that will be equal to 2 times half LH, which is LH. You understand? You can find L if you are given H. You can find H if you are given L. So, and you know the relationship between L and H is equal to L into root of R squared minus L squared. That is it. And you also know that H, this H is equal to half times length of chord. So this thing is very simple. Just break it down in a way that you will simplify it. Since I can now find the area of sector, area of the inside triangle. So area of segment now will be equal to, let me find the area of segment. So area of the segment will now be equal to area of sector minus area of triangle AOB, which will be equal to theta over 360, this angle here, times pi r squared minus LH or L times half AB. Anyhow, I know how to get L. L will be r squared minus half AB, whatever way. So I just show you the pattern to do this thing. So you can apply it to anything when you come to measurements under circle. So we have been able to talk about mensuration in circle. Mensuration in circle. Now there are some things that we can also do from circle. We can cut out some parts to form cone. Cone from circle. If you have this understanding, it will make some calculation very easy under cone. You see, when we have a sector like this, and we fold it, it will now give us a cone. You can see, it will now give us a cone. In this cone now, this radius here will become the slant height of this cone. The slant height, let me call this base H. The slant height of the cone. This arc here will become the circumference of the circle under this, the cone. So this one here will become the circumference of this circle now. You can see. So our calculation becomes very easy and simple. Another thing, due to the nature of matter can neither be created nor destroyed. The area of this sector will be equal to surface area of the curved surface. Not the full, but of this curved parts. The surface area here will be equal to the area of this curved parts. Now let's see how it is convertible. You know that here we are going to have theta. For circle now, and for cone, R here will become H here. R here becomes H here. Here, you see that we have a smaller R here. You can find relationship between this one and this one here. You will see. The length of the arc here of arc equal to theta over 360 times 2 pi r. You can see. Here, this one is equal to the length, circumference of base, which is equal to pi 2 pi r. 2 pi r. You can see 2 pi r. So if these two are equal, I can easily find r, the base, whatever here. So if I know the radius here, I know. And at the same time, r is equal to h here. But I cannot just pick it because I formed it from this place. So let's relate it to this one. Therefore, theta over 360 is times 2 pi r is equal to 2 pi smaller r of the base of the cone. So this one cancels this. Therefore, the radius of the circle of the base of the cone is equal to theta over 360 r. Simple. Simple. So now let us look at the area of this one and the area of the curved surface. Now please take note of this formula. R equals theta r over 360. Because I might need it again. Now, what is the area of the sector here? Is equal to theta over 360 times pi r squared. The area here, let's see what it will be. So, area here, let me break this one down. It's going to be theta over 360 pi, theta over 360 r times pi r. You understand? And if you look at it, theta over 360 r is equal to r, small r, the area of the base, the radius of the base, pi h, because r is equal to h, as I pointed out from the beginning. So, surface area of the curved parts of the cone is equal to pi r h. Some people use L, might be called pi r L. So I'm trying to break it down for you so that you don't need to do any extra or serious studies, just revision. So you can see. So surface area of the cone is pi r times slant height, because this one is converted to this one. Please, I hope you understand. And now, we want to find the total surface area of the cone. Total surface area is going to give you total surface area of the cone will be equal to area of the slant side plus area of the base. Area of base plus curved parts. So that will be equal to pi r height plus pi r square. So you can see, very simple, very easy, very straightforward. So we can do so many measurements, calculate so many things in our circle, in our cone, by converting the idea from this place to that of the cone. So this is just introduction to the next part I want to handle in circle. So if you have followed up to this part, thank you very much. And I also like to remind you to subscribe, share, comment, and follow in other media. Thank you very much. Next